welcome to the final episode in this series of 5 short videos to help you to be prepared for the start of A-level chemistry. This video is on a key topic the students can quite often get confused with, particularly the difference between alkalis and bases. So let's go in alphabetical order and start with acids. Acids release hydrogen ions in aqueous solution, and the most common acids that you need to know the formula for are hydrochloric acid, and the state symbol for acids is always aqueous, which means dissolved in water. So we've got the formula for hydrochloric acid, the formula for nitric acid, and the formula for sulfuric acid. They're the 3 most common acids. You need to know the name and the formula. They are all strong acids. Now, what does that mean, strong acid? It means that the acid fully dissociates, fully splits up into ions. So for example, hydrochloric acid will fully split up and releasing H plus ions, whereas a weak acid will partially dissociate into ions. And a good example of that is an organic acid like ethanoic acid, and the arrow that we use is a reversible arrow because it doesn't completely split up, it partially splits up into ions. Now, an acid, we have already said this, an acid releases hydrogen ions, which we call protons in aqueous solution. Therefore, you can also have a definition for an acid that an acid is a proton donor. It donates, it releases hydrogen ions. And therefore, a base is a proton acceptor. And examples of bases are things like metal oxides, and the state symbol will be solid, like magnesium oxide. You've got carbonates, for example, calcium carbonate, sodium carbonate. They're an example of bases. And also you've got alkalis. So alkalis is a type of base, a soluble base. For example, sodium hydroxide. So an alkali is a soluble base which releases hydroxide ions in aqueous solution. So for example, sodium hydroxide. In water, it will release hydroxide ions. Another example is ammonia. So ammonia with water will release hydroxide ions. Yeah, maybe a way to think about this is an alkali is a soluble base, therefore an alkali is aqueous. So again, starts with an A. An alkali is aqueous, soluble base. Acids react with bases to form salts, and this is called neutralization. And a salt, therefore, is the product. So you always have the salt on the right-hand side, the product of the reaction. And the definition of the salt is when the hydrogen ion from an acid is replaced with a metal ion or an ammonium ion. So we're going to have a look at some examples here to show this as an example. Salt is the product. So if you take an alkali, like sodium hydroxide, and react it with hydrochloric acid, then you have the formula there for hydrochloric acid. And we're going to replace the hydrogen ion, going to replace it with a metal ion. And that is the salt, sodium chloride, plus water as well. And if the acid is hydrochloric acid, the salt will always be called chloride. So like sodium chloride, magnesium chloride. Another reaction is a base, a metal oxide. So a metal oxide, which is solid, insoluble, and sulfuric acid. So what's the formula of the salt going to be? Well, the salt is when you take the hydrogen ions and replace them with a metal ion. So the formula of the salt is going to be copper sulfate CuSO4 plus water. And that is when you have sulfuric acid, you will get the salt sulfate. And then finally, if we have a carbonate and nitric acid, let's form the salt. We've got nitric acid. Let's replace the H plus ion with the calcium ion. But in order to make it 0 charge overall, we're going to need 2 nitrates. So the formula of the salt is Ca brackets NO3 2 plus water plus CO2. And if your acid is nitric acid, then you're going to make a nitrate. We also need to balance the equation because we need 2 nitric acids. Yeah, and these are called neutralization reactions. Okay, so again, that's just a really quick reminder of what you learned at GCSE, and in order to help you to prepare for the start of A-level chemistry, I'll make a worksheet for some practice questions for you as well, and I do hope you found this helpful, and thank you for listening.